In this video, we will explore what LLMs are, how they work, where they are being used, and what the future holds for them. Large language models are advanced AI systems trained to understand and generate human-like text. They are built on deep learning techniques, primarily using transformer architectures. These models power tools like ChatGPT, Google Gemini, Claude by Anthropic, Meta's LLaMA, and Mistral, among others. By the end of this talk, you'll have a solid understanding of how LLMs function, their real-world applications, and the challenges they pose. LLMs owe their power to the transformer architecture, a breakthrough in AI introduced in 2017. Unlike earlier AI models that process text sequentially, transformers use self-attention mechanisms to analyze entire sentences at once. This allows them to efficiently capture relationships between words, regardless of their position in a sentence. Transformers also enable parallel processing, making them more efficient than previous AI models. This technology is the backbone of all modern LLMs, including GPT, Gemini, and Claude, and has revolutionized the way machines understand and generate language. To understand LLMs, let's break down their three main stages. Pre-training. The model is trained on massive datasets, including books, websites, and code, learning grammar, facts, and language patterns. Fine-tuning. After pre-training, LLMs are refined for specific tasks, often using human feedback through reinforcement learning from human feedback, RLHF, to improve response accuracy and safety. Inference. When you use an LLM, it predicts the next word based on the context, generating responses in real time. LLMs essentially predict text using probability and pattern recognition, which makes them powerful but also prone to errors. At its core, an LLM is just a very advanced autocomplete system. Think about how your smartphone suggests the next word when you type a message. LLMs work similarly, but at an enormous scale. Instead of predicting just the next word, LLMs can generate entire paragraphs, write essays, or even code programs, all based on patterns learned during training. This analogy highlights both the strengths and weaknesses of LLMs. While they generate human-like responses, they don't truly understand language the way humans do. They are predicting what is likely to come next based on patterns. There are several LLMs available today, each with unique strengths. GPT-4, OpenAI, excels in reasoning, writing, and coding. Google Gemini, a native multimodal AI, meaning it can handle text, images, and even voice inputs. Anthropic Claude focuses on safety and alignment, designed to be more ethical and reliable. Meta LLaMA, a powerful open-source model, allowing developers more control and customization. Mistral 7B, an optimized, smaller model that delivers impressive performance with fewer resources. Each of these models has different capabilities, making them suitable for different tasks. LLMs are being used across many industries. Let's look at a few key applications. Content generation. LLMs assist in writing blog posts, scripts, and marketing copy. Programming assistance. Tools like GitHub Copilot help developers write and debug code. Customer service. AI chatbots are automating support, reducing wait times. Healthcare and research. LLMs summarize medical documents, help doctors with diagnoses, and assist researchers in analyzing large datasets. Finance and business. LLMs analyze risk, generate reports, and automate administrative tasks. These applications are just the beginning. As models improve, their use cases will continue expanding. Despite their power, LLMs have significant challenges: bias and misinformation. Because they learn from human-generated data, they can inherit biases or spread misinformation. Hallucinations. LLMs sometimes generate incorrect or misleading information that sounds authoritative but is completely false. Computational costs. Training and running LLMs require enormous computing power, making them expensive to deploy at scale. Privacy and security risks. LLMs can memorize and leak sensitive information, posing ethical and legal risks. Developers and researchers are actively working on solutions, but these challenges remain major obstacles to widespread adoption. What's next for LLMs? Smaller and more efficient models. Future models will be optimized to run on personal devices instead of relying on cloud computing. Multimodal AI, LLMs, will expand beyond text, incorporating vision and speech to interact more naturally with users. Better alignment and truthfulness. Improved training methods will reduce bias and misinformation, making AI more trustworthy. Integration with business workflows. LLM-powered AI assistants and co-pilots will become standard tools in workplaces, enhancing productivity. Regulation and ethical considerations. Governments are working on new laws to regulate AI use and ensure safety, privacy, and fairness. AI is evolving rapidly, and these improvements will shape how LLMs integrate into our daily lives. Let's recap what we've learned. LLMs are powerful AI models trained to predict and generate text. They function as advanced autocomplete systems, using probability to predict words in context. Their applications span multiple industries, from writing and coding to healthcare and finance. Challenges remain, including bias, hallucinations, and high computational costs. The future of LLMs promises greater efficiency, multimodal capabilities, and improved ethical standards. Thank you.